In this tutorial, we're going to take the vectors we created in the companion video and we're going to show you how to create a small inlaid sign. We're going to readjust the size of the vectors a little. We're going to add an additional vector so that we can go ahead and create a pocket in the part that you can see here. And then most importantly, we're going to show you how to create some inlay toolpaths. First, we're going to create this female inlay that you can see on the screen. This is where we're going to machine down these pockets, allowing for the radius of the tool, so that when we go ahead and show you how to create the male part of the inlay, which is the pieces that are going to slot into this pocket, that it will have accounted for the tool radius and all the parts will fit together correctly. So let's go ahead and start a new copy of the software. If you've just completed the vector drawing part of this tutorial, then you can continue with the file that you've created. Otherwise, you'll need to go to Open an existing file, and from the project folder, you can select us_buckle-vector.crv. This is the file that I saved that has the vectors that I created in that original companion tutorial to this. If we look on the Layers tab, we can see that we have the original bitmap layer where we imported the image, and we just have layer 1. We don't really need any more complexity to the layers than this. What I am going to do though is just undraw the visibility for the bitmap layer, so we just have the layer switched on where we can see and easily select the vectors. So let's now go over and down to the Drawing tab again, and let's check the size of our vectors before we create toolpaths. I'm going to just drag a box around them with the mouse, select them, and down the bottom of the interface you can see that the width and the height is displayed for me. That's this W and H value here. So the width of that vector is 9.8 and the height is 5.9 inches. I'd actually like to scale that a little bit. We might as well make it 10 inches by 6 inches. So I'm going to come over to the Transform Objects, click on the icon to set selected object size, and I'm going to type in a width of 10, and we can see that the height is automatically scaled because I have this link XY button checked. If I want to make that a specific value that's different, then what I would need to do is uncheck that, put in a height of 6. Now when I hit apply, those vectors are going to be scaled to be exactly 10 inches high by 10 inches wide by 6 inches high. So let's go ahead and close that. So for this part, the idea is we're going to cut out some letters, the U and the S, and also cut pockets for those to inlay into within this part here. In addition to that, I'd like to have a small border around the outside, so I'd first want to pocket out the middle part of the oval. To allow us to do that, I'm going to offset this outer vector inwards in order to create that inner boundary that I'm going to pocket out. So I'm going to select just the outside vector, so you can just deselect all the vectors first, then click on the oval, come down to the Offset Selected Vectors icon. I'm going to click on that, and I'm going to offset this inwards, and we'll offset this inwards by 0.35 of an inch, and go ahead, hit offset, and that has now created that border shape around my part. If we close that now, I think we're ready to go ahead and start thinking about creating toolpaths. So we can come up to the icon here, switch to the Toolpaths tab. When I click on that, it will minimize the Drawing tab and open up the Toolpaths tab on the right hand side of the interface. So as I mentioned before, for this particular job we're creating an inlaid part. The U and the S will be cut from one piece of material and inlaid into a different piece of material, which will be the oval and the pockets for the U and the S to fit into. To do this, we'll need 2 sessions of Aspire. We'll calculate the toolpaths in 2 sessions of Aspire so that we can make sure that our setup for each set of toolpaths is correct. So in this session, we're going to create what is essentially the female part, which is the pocketed oval, and then the pockets for the U and the S that the letters are going to fit into. And then we're going to copy the U and the S into another session of the software and create the male inlay cutout for those, and those will be the parts that will actually go into this one. So here, let's set up our material. I'm going to come up to the material setup, click on the set button, and in this case we're going to imagine we're working with 3/4 inch material. I'm going to go with 0.75 inch material. And now you remember that we did our drawing for this with the datum set in the middle. This is often quite a nice way to do it because you can make sure things like the ovals are centered on 0, 0. Now I'm coming to machine this. My preference is actually to machine with the datum in the lower left hand corner. So I'm going to click on that and move the datum down to the lower left hand corner. That means where that red square is now shown is going to be 0, 0. X0, Y0 is going to be here, and everything I toolpath and then cut on my machine will be referenced from that point. Need to come down and double check that my rapid gaps are reasonable and my home start position is reasonable too. May just edit that to be X0, Y0, and in this case Z 0.5, and we'll hit OK. Of course, with all toolpath examples, if you're planning to cut this, you'd need to make sure that the settings were appropriate for your particular setup. So let's start with a simple pocket toolpath. I'm going to select this inner oval, come over to the pocket toolpath icon. In this case, on a start depth of 0, a cut depth of 1/8 of an inch, 0.125, and we're going to select a 0.25 inch end mill and just check the settings quickly to make sure they look reasonable for what you're doing. Apply and OK. In this case, I'm going to do an offset to clear this pocket out, and so we'll just call that toolpath pocket and hit calculate. So there we've gone over into the 3D window so that we can see the preview. I'm going to come up and say preview selected toolpath and just check that's cutting the area that I want. If I want to speed things up, I may want to choose to undraw the animation so that that will go a little bit quicker next time. We can see we've just got a simple pocket milled down to 1/8 of an inch. What I'm going to do now is click on the 2D view again, and now what I want to do is create the pocket that the letters are going to inlay into. Now what's very important now is that I need to use the specialty inlay toolpath. So let's close the preview. I'm going to box select just the U and the S and come over to the inlay toolpath icon. I'm going to click on that, and in this case I'm making the female inlay pocket. So we're going to click under female inlay. I'm going to click the button that says pocket. Now you'll notice that the inlay pocket toolpath form looks very similar to the regular pocket toolpath form. The only real difference is this pocket allowance down here. We'll talk about the importance of that in a moment. But what's going to happen when we use the inlay toolpaths is they're going to automatically allow for the fact that the corners need to be rounded. If we think about the fact that the tool we're using is round, and when it cuts something out, the external corners will be cut correctly, but the internal corners will always have the roundness of the tool on them. So when we're doing an inlay, both the pocket that the inlaid part is going to go into and the part itself need to have their corners rounded off. For the part that, for the pocket where the part's going to be inlaid into, it needs to have its internal corners rounded. For the part that's going to be inlaid, it needs to have its external corners rounded, and we'll see the effect of this from the toolpath in a moment. What's very important when I'm cutting the inlay is that I use the same tool for the pocket and the same tool for the part that's going to be inlaid into it as well. Because the software's automatically accounting for the radius of the tool, if I don't do that, then the two parts won't fit together correctly. In addition, the pocket allowance allows me to specify an extra distance which will give me a little bit of play between my two parts. If I don't put any allowance on it at all, then it will be too tight a fit for my parts to go together. That pocket allowance can also be used to allow for any finish you might be adding to the part which might give it additional thickness, such as a paint. So in this case, we've got to remember first of all that I've already milled down 1/8 of an inch for this oval. So I want my start depth to be 1/8 of an inch. There's no point cutting air of a part that I've already machined. Then I want to cut a further 1/8 of an inch down from that, so my cut depth is going to be 1/8 of an inch. So that means that the toolpath will start 1/8 of an inch into the part already, which is okay because that's an area we've already pocketed, and then go a further 1/8 of an inch into that. I'm going to use the same tool we used before, the 1/4 inch end mill, and that is quite a big tool for doing an inlay, but the reason I'm choosing that is because it'll allow the effects of the inlay toolpath to be very obvious. Then, as I mentioned, we want to come down and do a pocket allowance. In this case, I'm going to allow, say, 1/100th of an inch, 0.01, and that'll just oversize this pocket by 1/100th of an inch, which will give us a better chance of the inlaid part fitting into it. Again, you'd want to investigate appropriate values for that depending on your material, your tooling, and the type of how tight of a fit you're trying to generate. So we'll call this toolpath pocket inlay, hit calculate, and if we preview that, then we'll see what that looks like. Now we can see that that has quite rounded edges, and if I go back to the 2D view, what we may want to do is just close this, select that, and choose the option for solid preview. The solid preview will show us how this toolpath is rounding off the corners. So this roundness is to do with the shape of the tool itself. That's just the radius of the tool. But here you can see that it's cutting past this corner, and that's to allow for the fact when we cut this out that there'll be a radius on that internal edge. You can also see that this is coming a little bit past the edge of the part here, and that's that pocket allowance we set. That's why it's coming outside of the vector. So now let's go ahead and do the profile to cut out the part. I'm going to select the outer oval, come to the profile toolpath. In this case, we're going to cut all the way through our 3/4 inch material. Use the same tool as we've used for the other toolpaths, 0.25 inch. And if we wanted to, we might want to edit the pass depth for this. Maybe we could afford to be a little bit more aggressive in the material we're cutting, so we'll edit that to be 0.25. That'll reduce the number of passes to 3. I'm going to cut on the outside of this, and I'm going to add some tabs to this. Let's hit edit tabs and say that we want 4, hit add tabs and close. We just check the values there. They're reasonably big tabs. Maybe we'll reduce that to 0.1 and this to 0.25, so the length is 0.25, thickness 0.1, and I'm going to change the name of that to profile cutout, hit calculate, and then again we can preview that, see how that's going to look. And there we can see the tabs holding the part in place, and so there's the female part of our little inlaid plaque. Now interestingly, we'd actually be better off to cut this second, and the reason for that is if I cut out the letters first, then what I can do is after I've machined the pocket for this, I can check the fit, and then if the fit is not exactly right, I might want to increase the pocket allowance. So in effect I might start with a smaller pocket allowance, cut that toolpath, see how the fit is for the inlaid letters. If the fit could do with being a little bit bigger, then I could increase the pocket allowance, recalculate the toolpath, run it again and check the fit until I'm happy with it. So as I say, in some cases you'd be better off to cut this part second. What we're going to do is calculate the male inlay toolpaths for the U and the S now. So I'm going to click on the tab here and I'm going to select the U and the S. I'm going to right mouse click and I'm going to go to copy. What I'm now going to do is start a new session of the software. In here, I'm going to create a new file and I'm going to go ahead and make a part here big enough for me to fit those letters into. Now I might want to check my other session, and with those vectors selected down the bottom here, I can see that the width of them is 6 1/4, the height is a little over 3 inches, and so what I can do is go back into this session here and maybe make it so that my width is 8 and my height is 4 for my material. Now this inlaid material I'm going to imagine is 1/2 inch thick. I'm going to set up the XY datum position to be in the lower left because we're pretty much going to go straight to machining. Hit OK, right mouse click in here and go to paste. And you can see that paste in the position it was in the original file, and what we can do is come over, align selected objects and click on the icon here to center in the middle of our material. Close that. Now I can either click on the icon here to go across to the Toolpaths tab, or we can hit F12, the function key F12 on the keyboard as a shortcut key to close the drawing tab and open the Toolpaths tab. Just double check my material. I know we just set that up, but it's worth checking those values and also checking my rapid Z-gaps, my home start position. I'm happy with that, so I can hit OK. And now we're going to come to the inlay toolpath, and this time I'm going to do a straight male inlay. I want to cut these parts out in a way that they will inlay into those pockets we cut on the other part of this job. So male inlay, click on the button that says straight. Cut depth is going to be the depth of my material, 0.5 of an inch. Remember, it's very important I use the same tool that I used to cut the pocket for the other inlay. So we're going to use this same 1/4 inch end mill, 0.25 of an inch. If we want, we could add tabs to these letters to hold them in place while we cut them out. So I may want to click on that, add tabs. I'm going to edit tabs, and we'll just go ahead and click to add tabs in some appropriate places. Hit close, hit calculate. There's my toolpath. If we preview the selected toolpath, we should see how much that is rounding the outside of the letter again, and that's rounding those in order that they will fit into the pocket we cut on the other one. Here we can see these two letters are quite close together, so if we wanted to, what we might do is space them apart a little bit more. So I could come back to the 2D view, right, deselect, select on the U, just use the arrow key to jog that over, select on the S, use the right arrow key to jog that over. Then if we close the preview, we can select the toolpath, click on the icon to edit that toolpath, and now if we hit calculate, it'll calculate that in the new position. What I want to do is say reset preview, preview selected toolpath, and there we can see how that part's going to look once it's cut out. We can see the material that's going to be left. Again, I might look at this now and decide that I'm not happy with the position of this tab here. So we can come back to the 2D view, close the preview window. Again, we could select this and click on the edit icon, or we can just double click the toolpath name in order to reopen it. Click on the button to edit tabs and move this around. Maybe we'd like to move that right out the way there, move this one around here, and add in an additional one here just by hovering over that. When I get the check mark, I can click to add a new tab, can close this and hit calculate, reset the preview, and preview the selected toolpath. Once I'm happy with this, then I'm ready to go ahead and output it to my machine. So I'm going to hit close on the preview. If we were going to save this to the machine, we'd choose the toolpath, come up to save toolpath, we'd choose the appropriate processor from the list, hit save toolpath, and that would be our male inlay toolpath that we'd cut into the 1/2 inch material. As I mentioned before, there could be some benefit to cutting that first, because after we've machined this, we could go ahead and machine the oval part that we created, and as we machine the pockets for that, we could check for fit with these inlaid with the male inlays that we'd already cut. So at this point, we've pretty much concluded this particular tutorial. What I'm going to do is save these files so that you can review them if you want. For this one, we'll say File, Save As, and in the project folder, we'll call this US Buckle Male Inlay TP, so that we know it's the male inlay and it has the toolpaths in it. We'll go ahead and hit save. So File, Exit, and then for this one here, again, if we wanted to, we could go ahead and save our toolpaths now. We could save out the pocket inlay, and the profile. Remember, they've all been cut with the same tool, so we could select each one, make it visible, put the check mark in here, go to Save Toolpath, say output all visible toolpaths to one file, and because they're the same tool, they'd just be appended together in the order that we see them here. So it'd be important to review and make sure that the profile cutout was the last thing that we were going to machine with this single file that we would save when we went ahead and hit Save Toolpath for those. Again, once I'm happy with that, I can say File, Save As, and this time I'm going to call this US Buckle female inlay TP and save that in the project folder if you want to take a look at this file. So to briefly review, we started this tutorial with the artwork we created in the companion video, where we imported the photograph of the US buckle and we used the guidelines in order to create the vectors. What we were then able to do here is take those vectors we'd created, we resized them, we added an offset vector to create our inner shape for the border. Then we went ahead and generated the 3 toolpaths for this female part of our inlay. We pocketed down to create our inner pocket. Then we went ahead and used the female inlay pocket to cut out the holes that we were going to inlay the letters into. And we created a profile toolpath to cut out this part. Then we took the 2 vectors that we wanted to create our male inlay, copied them into another session of the software, and went ahead and used the male inlay toolpath in order to create the toolpaths to cut those out so that they would accurately fit into the pocket that we created in this part of the job. Important things to remember in this are the fact that you always need a pocket allowance when doing an inlay, either on just one side of it, so in this case we only added it on the female part of the inlay, or you may want to offset both sides of your inlay. You might want to reduce the size of the male inlay a little by providing that with a pocket allowance as well. And it's also very important that you use the same tool for both the inlay toolpaths, otherwise an incorrect offset will be applied to the radius of the tool. That concludes this tutorial.